All right, we're going to take a look at our last lesson in Chapter 5 of 5.6. So we're going to take a look at these angle bisectors and perpendicular bisectors. We've already used those in some of our proofs, and now we're going to look at some of the properties, things that happen once we bisect an angle and once we bisect a segment. So our vocabulary. When we talk about the distance from a point, we're going to use that in one of our theorems. It's just the length of the perpendicular segment from the point to a line. So when we're talking how far apart a point is from another line, that means we're drawing a perpendicular segment, not a curve or a smooth line. Equidistant, it means where a point is the same distance from one line as it is from another. So we see equa and we think of equal distance. It just means they're the same distance, which is nice because then we can start making congruent sides. And then a perpendicular bisector, and I believe this is a review term for us if we check back in Chapter 1 or Chapter 2. But a perpendicular bisector is just a segment, ray, or line that is perpendicular to a segment at its midpoint. So we have to have two terms there. We need to be perpendicular, so we have to make that 90-degree angle, and we have to hit at its midpoint, which was, once again, in these congruent triangle chapters is nice, because then I make congruent segments on each side for congruent sides of our triangle. All right, so let's take a look at this first theorem here, the angle bisector theorem. So it says if a point is on the bisector of an angle, then it is equidistant, so it's the same distance from the two sides of the angle. So if we look at the picture of that, we have this angle bisector, and we have point P on that. And so what we're going to talk about is the distance from B to the top ray and then B to the bottom ray. What we've done here is we've created two congruent angles. So we have angle 1 and angle 2 because we bisected angle A. So if we look at the then, it means it's equidistant from the two sides. So that means BC is congruent to DB. We have these equal angles. So if the measure of angle 1 is equal to the measure of angle 2, so if we have these two equal angles, then we know BC is congruent to BD. Okay, so if we have equal angles at the top of what looks like two triangles, then we know the sides opposite those are going to be congruent. So now how can we use that in a proof? So in the diagram, we know UW, ray UW bisects angle to TUV. So we have angle TUV, and we have ray UW. It bisects it, so that means these angles are congruent up here. We then know that angle UTW and UVW are right angles. We want to prove that the two triangles are congruent. So we start our statements with our given. So UW bisects angle TUV. The reason we know that is given. And so the definition of an angle bisector is our reason. Well, we just bisected an angle, so I need to tell you what two congruent angles you created. So you created angle TUW, so TUW, and angle VUW. Those two are the congruent angles, and we already drew that in there. We know that WT is congruent to WV, so these sides opposite are congruent. That's this angle bisector theorem, that once we bisect the angles, the sides opposite those are going to be congruent. UTW and angle UVW are right angles. That was part of my given information. And so now I know that angle UTW is congruent to angle UVW because all right angles are congruent. So let's go back and look what we had. We had congruent angles, we had congruent sides, and then we had congruent angles. So it's either ASA or AAS. If we look, that segment is not between the two angles, it's angle, angle, side. So we use our angle, angle, side theorem. All right, so what we want to do now is write the three congruency statements that show how the angle, angle, side theorem was used. So we start with the angles. We had angle TUW was congruent to angle VUW. We then had to have another angle. So we had angle UTW, our right angle, is congruent to angle UV BW. And now I want you to finish in class. I want you to tell me what side we used and write its congruency statement. So this we will check in class. All right. Theorem 5.4, we have our perpendicular bisector theorem. And so what that says is that a point is on a perpendicular bisector of a segment. So we can see that line CW is the perpendicular bisector because it's a 90-degree angle, and we have congruent sides, so it meant M was the midpoint. Then it is equidistant from the endpoints of the segment. That means when we connect C to A, the endpoint, and C to B, the other endpoint, we create two more congruent sides. So, if C is on the perpendicular bisector of AB, that means CA, that segment, is congruent to CB. The point gets connected to both endpoints, so we create two new segments. So let's take a look at how we can use that in example 2. So we have the diagram, and we want to find AB. So we know that AC, we know this line is the perpendicular bisector. I have a 90-degree angle and two congruent segments, so that's perpendicular bisector of DB. And so the perpendicular bisector theorem tells me that AB is congruent to AB. So they're equal segments. So if I look at my algebra, I can take AB, this AX, and set it equal to 5x plus 12. If they're congruent, I can set it equal to each other. Then I'm going to go through and do my math. I'm going to subtract 12 from each side. I'm sorry, not 12. I'm going to subtract 5x. Sorry guys, I was looking at the corner of my eye. So when I subtract 5x from 8x, I get 3x is equal to 12. Divide each side by 3, and we get x is equal to 4, which is great. Yay, we found x. You need to make sure you get finished with your problem so that we go back and read what we wanted to find. It didn't say to find x, it said to find AB. So if we look, AB is 8x. So that means now it's 8 times 4, which is 32. All right, so that segment, AB, is 32 units long. If we take a look, the follow-up that goes with this is they want you to check your answer by finding AD. And so what they want you to do here, we'll put it in split screen for a little bit, is they want you to find this AD. So they want you to take 5x plus 12, knowing that x equals 3, and then, x equals 4. My board's messing up here, guys, so sorry about that. X equals 4, and they want you to find out what that actual length of AD is. All right, let's take a look at the checkpoints. They want me to find FH. And so FH is this segment here. And so what I need to use is I need to use the fact that I know, because this is an angle bisector, I have my two congruent angles up here at the top, I know that x plus 3 is equal to 2x plus 1. We're going to use our algebra and subtract x from each side. So 2x, take away the 1x from the other side, leaves me with 3 equals x plus 1, minus 1 from each side, and we get x is equal to 2. Once again, go back and look and see what they wanted you to do. They wanted you to find FH. FH is equal to x plus 3, so I need to plug 2 in for x, and I get FH is equal to 5. And so what I want you to do now is I want you to do number 2 and number 3. We will check in class. And so what that means is you need to do those now. So for those of you that conveniently forget to do these, let's pause the video. We'll have you pause it, and then you can just do those 2 problems right now. All right, our last one, we're going to use this perpendicular bisector theorem in a proof. So if we take a look at that, in the diagram, MN is the perpendicular bisector. I know that because there's a 90-degree angle, and I have my congruent segments. So MN is the perpendicular bisector of ST. That's given. What I'm trying to do is prove that these two triangles are congruent. So what that means is MS is congruent to MT. Remember, we said that if I connect M to the two sides, to the two endpoints, I create congruent segments. So that means M connected to S was congruent to M connected to T. If we look at that, I have two congruent sides. I have MS is congruent to MT. Well, that's the definition of an isosceles triangle. So we prove that our two triangles were isosceles. So that's one way that we can use that perpendicular bisector theorem. Ladies and gentlemen, enjoy your video and make sure you go back and do your checkpoints. And that's